Okay, so this time I'm recording this question. This is binary tree level order traversal. So it is a medium type of question, but see, it is a easy question. But see, they have slightly LeetCode have slightly changed this problem. Let's see what is that. So given a root of binary tree, return the level order traversal of its node value that is from left to right and level by level. So you must know what is level order traversal. Let me tell you how. Copy image and I'm pasting it here. Yes. So see, its level order traversal is like this. First like this, then it is like this, and after that it is like this. Yes. So 3 comma 9 comma 20. Yes. And comma wait. Okay. So let me write it again in a proper way. So its level order traversal would something like this. 3 comma 9 comma 20. Not 10. It's 20 and comma 15 comma 7. Yes. 15 comma 7. Yes, so this is its level order traversal. And if you see, but output is different here. LeetCode has changed this. That's why I was saying they have slightly changed this question. Why? They have combined the order level. See, first level is 3, so they have made an array of 3 and then they have pushed it to the answer. Second order is 9 comma 20. Yes, 9 comma 20, so they have put it inside an array and then pushed it to the answer. Yes, and just like that 15 comma 7. And suppose if there another node after 9, suppose 4 and 5 are also there. It's 4 also there and a 5 node is also there. So answer will have, oh wait, answer will have 15 comma 4 comma 5 comma 7 comma 15. Then answer would something look like this, would be looking like this. 4 comma wait again 4 comma 5 comma 15 comma 7. Then our answer would be this, an array closed. See, I haven't closed my array. Okay, so then it would look like this. But see, right now we do not have, so I won't include that. That would make your answer complicated, I would say. So see, I'm removing this and not that. I'm just removing these nodes which I made. Yes. So that's our output, and see, that's the output. We have to return 3 9 20 and 15 7 in combined form. Yes, so this is our output. So how can we do this? So whenever level order traversal comes to us, we always think about BFS. Yes, breadth first search. So but see, what can in that we can use a queue. We use a queue in that. So how to use that queue, let me tell you. I'm removing this, and see, I'll make a queue like this. And see, I will push first 3. Yes, 3 inside it. Okay, 3. Then I will do what? I'll see that this is my level. What is the size of my level? Right now size of my level is 1 because queue dot length is 1. So I will push 3 inside in my array like this. Yes, I'm just doing it here only. Okay, I'm pushing 3. Then I will pop it out. Means I will shift it. So I'll pop like this. This 3 will gone. Now I'll push its siblings into this. So its siblings are 9 comma 20. Yes, 9 comma 20 are its siblings. So I'll again now check stack dot length is 2, and see this level dot length is also 2. Size of this level is 2. So I will again I will again run a loop till 2 times. Okay, and I will push all these values inside an array, and then I'll push that array into the answer. Then I'll go to my next level. Suppose I said this level was 4 comma 5 also were included in this level. Suppose this 9 is connected to 4 comma 5 like this. Okay, so this 9, suppose this 9 is connected. So I'm changing my answer slightly. So this 4 comma 5 comma 15 comma 7, then this would be our answer. Okay, I'm changing it just for you, so you can understand it better. So see, our length is 2. So stack dot length is 2. This is popped. This 3 is popped. Okay, this 3 is popped. Stack is only like this only, 9 comma 20. Yes. So see, now what will happen? We'll pop this 9 out. We will do stack dot length is 2. We will run a loop. We'll pop it out and we'll push its children inside it, which are 4 comma 5. These are its children. Yes, we'll push them, and then we will pop this 20 also out, and we'll push siblings of 20 also, 15 comma 7. Yes, 15 comma 7 like this. Okay, we have done 2 iterations. We have to do it 2 operations. We did that. So we had to do 2 operations. We did that. So now I'll make an array of 9 and 20 and I'll push inside it like this. Now four operations. Stack dot length is 4. See, we have popped them out. So stack dot length is this much only. Its length is 4. Yes. So we have to do four operations now. We will run a loop to 4 till 4 and we'll push all those value to an array, and then after that when loop finished and stack dot length is 0. After some time the stack dot length is 0 and I'll push that to this ANS. Okay. And that's how we will do that traversal. So there is a way of recursion also. I will tell you that. First, I will write code for this. Let ANS is equals to this blank, and let stack is equals to an empty stack. Yes, and see, empty stack. Can I take that? So yes, I can take that. So while, okay, while stack dot length is empty. So first time it would be empty, but current is there. Let current is equals to root. Yes, we can take that route to current. So right now my level is what? See, what can I do? Stack dot length is 1. So I will run a loop one time. So I can do something like this also. Stack dot length root. Yes. So initially my stack dot length will be there. So while stack dot length is there, and then what I will do? Stack dot length is there. So I will run a for loop. Let size is equals to stack dot length. Yes, length. Yes, and I'll run a loop. Let I is equals to 0 till I less than what? I less than what? Size. See, size is 1 first time. So I'll run a loop and I'll create an array also. Let arr is equals to an empty array. I'm just writing what I wrote there in this dry run. What I wrote, I'm just writing it in a code form. Yes, size. So size is right now 1 because stack dot length is 1. Stack only has this root. So loop will run from 0 to 1. That is one iteration only. I plus plus. Yes, and I will do what? Let top is equals to, let's say top is equals to stack. Oh, why I'm using the stack? Sorry. My bad. Sorry. Q. Yes, and q dot length I should write like this. So okay, q u e and size. Yes, perfect. So q dot length is so dot shift. Okay, I'm shifting it. Okay, and I will do what? I will push its value, push its left siblings, left and right, and what? QE UE dot push what? Uh, top dot left comma top dot right. Yes, I'll do this and then I will remove it out. See, I have removed it out here only. Now I have to just push it inside array. ARR dot push what? Push. I have to push this. Push what? This top dot val. See, I have to push its value. So okay. So are we doing it good? So okay, we will first push this 3. We will run a loop one time. So inside our this 3 was there. 3 was there. I said that 3 was there inside. Stack dot length was 1. Initially stack dot length was 1. Let me do it here. So initially stack dot length inside only 3 was present inside stack q only. Inside q 3 was only present. Then what we did? 3 was only present. We removed it. We pushed its sibling. Its siblings are 9 and 20. So we pushed 9 and 20 and we are making array of 3. Then I have to push. After that loop we have made that array. Now I have to just push that array. ANS dot push that ARR. Yes, we have to push. Now our size is 2. So that loop will run from 0 to 2. 0 to 2 are 0, 1, 2, 2 iterations only. So again, we will make an array of 19, comma 20 and we'll push its siblings also. Okay, so yeah, we are doing it right. Perfect. So a perfectly fine solution. So now what I have to just do? Return what? ANS. Yes. And suppose this test case. See, if I remove this test case, it will work properly. This code I think will work properly. Let's see. Uh, because we are doing everything right. Let's see if there is any mistake in there. So top dot left is not defined. Okay, okay. See, you have to check this. If top dot left exists, top dot left exists, then only you can do this operation. Else you cannot do this. Top dot right, yes, exist. Then sorry, my bad. I think now it is correct. Now it is correct, I think. So it shouldn't give me C. But there is another edge case. Suppose if that q dot length, see, suppose if root is not valid, if not root, then return an empty array. Why? Because if I do not write this, it will give you error. See why? I'm again making that test case. See, this test case, if I comment this line out, I'm commenting it. See, this will give me a runtime error, or what shall I say? Yes, this will give me runtime error. See, but if I uncomment it now, this will give me the right output, and this code will be submitted. So that's how we do BFS and breadth first search. And if I submit this code, this will be submitted. So we used queue here in level order reversal. So see, this question is easy, but the difficulty in this question, what makes this question difficult is this making of this ARR array inside ANS. That is difficult. And see this code. This is a 29 lines code, and we can do whole this code. We can code this whole thing in 3-4 lines by using recursion. Do you want to see that? Let me show you first. So how can I do this using recursion? So I can do one thing. Let me remove this all. Uh, okay, this will take time. Or let me just paste another copy image, and I'm pasting it here. Let me paste it here. So see, what can I do? I can maintain level each time. I'll call a function. Suppose the function is t. Okay, I'll call it with first time my level is 1. So I will call it with 3 comma 1. Yes, 3 comma 1. Right. And I will push its val to there is an array. I will see. Suppose I have an array. So explaining this is slightly tricky. So I'll try my best to explain this. And see, I will do what? I will create an ANS array. ANS, and see, ANS of 0 is ANS of 0. I will do ANS of 0 is 3. 3. ANS, see, this is my level. This is my level. I'm denoting with L. So I will write something like this. This is the pseudocode. ANS of level dot push what? Wait, ANS of level dot push what? 3 means current dot well. Current, let me write it completely. So current dot val, yes. So we can do something like this. So current dot val is 3. So ANS mein 3 push, we pushed 3 inside ANS, yes. So now if I go like this, so see, now I'll call the same function with next value 9 comma its level. I will increase its level by 2. See, and I'll again call this function with 20 comma 2. Yes, 20 comma 2. I'm not writing it properly. So see, 20 comma 2, we can do something like this. Yes. So if I call it with 9 comma 2, ANS of level is right now. So see again, sorry, I did a mistake. Okay, I did a mistake. I know what. First, for the first time, the uh, level will be 0. Yes, for the first time the level will be 0. Why? Let me show you. First let me toggle the level logged. Yes. So what I wrote is uh, ANS is equals to an empty array. Yes. And ARRC ANS of level dot push current dot val. Yes. So see, first time my level will be 0. Yes. So ANS of 0 will be like this, 3 current dot val. Next time I'll call the same function with, I will say call the same function traversal with 9 comma level plus 1, level plus 1, 9 comma level is what? 0 plus 1 is 1. I will call this function like this, and see, wait, I will call again the same function with 20 comma 1, right? I'll call the same function with 20 comma 1. So now see, level is 1. So ans of 1, ans of 1 is what? This is 0. So ans of 1 will become something like this. ans of 1 will wait. Okay, can I? Yes. So ans of 1 will become something like this. 9. Yes, I have pushed 9 inside it. And see, this code will do what? This will push ans of 1 to 20. Inside ans of 1, it will push 20. Yes. And then it will call the same function traversal with t with 15 comma 2 and uh, traversal, same function traversal with 7 comma 2. Yes, 7 comma 2. Just see this recursion and you will be amazed if you dry run this. This is a very good solution. And see, now 15 comma 2. This will again do. So current dot level, level is 2 now. This is 1, this is 0. So we'll do what? We will push it. Wait, let me edit this. Yes, push it to 15. And this line of code will push 7 to it, comma 7. Yes. So like this. And whenever we will call this function, and see, next time we will call this traversal with null, null, comma in an increased level, comma 3, null, comma 3. We will call it with. So whenever we get null, we will just return from that. So writing code for this question is very easy now. So what I have to do now? Let see again function spelling wrong. Function traversal, again wrong spelling. Traversal, yes, right. And I will call it with current comma level. Yes. Oh, level. Yes. Okay. So now what I have to do? See, somewhere I will call this function. That somewhere is here. Traversal. Traversal root comma level. Initially my level is 0. Yes. So if that current is not valid, suppose if root is not valid, if current is not valid, suppose, then just return from that code. Yes. And else what you have to do? So else you have to make an ans array. Let ans is equals to an empty array. I am writing just what I showed showed it to you in that here. So if not, so if my ans is empty, see, if my ans is empty, ans of level is empty, level. See, initially my ANS would be empty array like this. So ANS of 0 not exist. So ANS of 0 not exist. So what shall I do? If ANS of 0 not exist, ANS of level is equals to an empty array. Yes, I'll do something like this. Else, I have to just push ans dot push. See, if it not exist, make an empty array. Ans of level dot push. Ans of level uh, dot push. Sorry, there are too much spelling mistakes I'm doing right now. So ans dot push again. So ans dot push what? Push current dot val. Yes, current dot val. Again, very easy code. So ans dot push current dot val, and then I will call the same function traversal. Traversal function with what? Current dot left and level, level, again level plus 1. And I'm not typing it again because I'm doing a very much typing mistake right now. So right, see, and we will do it when if current dot, see, if current dot left is null, we cannot do this. So current dot left exists, then only call this. Then only call this. And if current dot right exists, then only call this. So right now my task is done, and now just I have to return what is inside. I want to see what is my inside ans. So I just want to see inside and see, let me see, is there any error? So ans is empty and I'm creating that function traversal, and if arrays of level not exist, so create that level like an empty array and push inside that level, push. See, I got a mistake here. So uh, ANS of level dot push current dot well. Now I am correct. And if current dot left is okay, okay, that's totally good. So if I run it, so it should run, and let me see if there is any error. See it, this code is accepted, runtime 0. And if I submit this, see, now our code is just like this. These how many lines are these? 3, 4, 5, 6, 7, 7, 8 lines. Okay, and initially our code was so long, and see, it is submitted in 2 milliseconds. It is submitted. So see, this code is also a good code. See, this was a huge code, and this is in, as if we compare to that, this is very less code. Yes, these 5 lines are doing everything for you. They are doing every traversal. So that's why I said recursion is important for this question. So that's my solution. I showed you both the approaches. This question can be done with recursion as well, and using queue as well. So it's up to you. Whatever you want to use, you can use that. But I would say that recursion is important for this question. So thank you so much, and have a good day.